Good morning. My name is Chandler M. Manlongat from CM124-1B-B12. So today we are going to discuss questions involving statistical analysis and balancing redox reaction. We are going to answer question 8-24 letter A and question 18-9 letter A. So for the question 8-24 letter A, the following atomic absorptions results were obtained for determination of zinc in multivitamins tablets. All absorbance values are corrected for the appropriate reagent blank. Concentration of zinc is 0.0 nanogram per milliliter. The mean value for the blank was 0.0 with a standard deviation of 0.0047 absorbance unit. So for the question 8-24 letter A, we have here table of values for the concentration of zinc with nanogram per milliliter and absorbance unit. So for letter A, find the mean absorbance values for the 5.0 and 10.0 nanogram milliliter standards and for the tablet sample. Find the standard deviation of these values. For the brief background, we have here statistical analysis pertaining to mean. According to Skug et al. 2013, the most widely used measure of central value is the mean. The mean is also called the arithmetic mean or the average. It is obtained by dividing the sum of replicate measurements by the number of measurements in the set, where xi represents individual values of x making up the set of n replicate measurement. Another formula is the standard deviation, where it is used to describe the precision of replicate data, where S is equal to sample standard deviation and N is equal to total number of sample elements and X is equal to sample mean. We are going to use Excel. First, we need to plot the data for the concentration. So in order to find the average, we have here the formula is equal to average open parentheses B5 colon D5, and for the standard deviation STDEV quantity B5 colon D5. The yields for the mean 0.04890 and for the standard deviation 0.002821. And for the overall sample mean is 0.06490 and for the overall standard deviation is 0.003081. So for the manual calculation or the sample calculation of mean, we have here the mean for 5.0 nanogram milliliter obtained by getting the sum of 0.0519 plus 0.0463 plus 0.0485 divided by 3 that yields into 0.04890 as the mean. So for the mean for the 10.0 nanogram milliliter, we have 0.0980 plus 0.1033 plus 0.0925 divided by 3 is equal to 0.09793 for the 10.0 nanogram milliliter. So for us to obtain the total mean of the sample, we need to add the mean from the 5.0 nanogram milliliter plus the mean from the 10.0 nanogram milliliter divided by 2. So we have here 0.04890 plus 0.09793 divided by 2 is equal to 0.6490. So for the calculation of standard deviation, um, we are going to use the formula. So standard deviation for 5.0 nanogram milliliter is equal to square root of quantity 0.0519 minus 0.04890 quantity squared plus 0.0463 minus 0.04890 quantity squared plus 0.0485 minus 0.04890 quantity squared divided by 3 minus 1 is equal to 0.002821. So for the standard deviation of 10.0 nanogram milliliter, we have square root of quantity 0.0980 minus 0.09793 squared plus 0.1033 minus 0.09793 quantity squared plus 0.0925 minus 0.09793 quantity squared over 3 minus 1 is equal to 0.005400. So for the total standard deviation, we're going to add the standard deviation from 5.0 nanogram milliliter and 10.0 nanogram milliliter divided by 2. So we have 0.002821 plus 0.005400 over 2 is equal to 0.003801. So for the summary, 5.0 nanogram milliliter yields into mean of 0.04890 with its standard deviation of 0.002821. And for the 10.0 nanogram milliliter, we have 0.09793 and its standard deviation is 0.005400. And for the overall sample, we have the mean of 0.06490 and standard deviation of 0.003081. And we were able to answer the said question. The mean is 0.006490 and the standard deviation is equal to 0.003081. So for the next problem, question 18-9, letter A, we are asked to find the balanced net ionic equation for the following reaction. Supply hydrogen and or H2O as needed to obtain the balance. So we have here permanganate plus vanadine ion that yields into manganese plus vanadium 4 hydroxide. For the brief background, what is a net ionic equation? The net ionic equation is the chemical equation that shows only those elements, compounds, and ions that are directly involved in the chemical reaction. So in order to write a balanced net ionic equation, we should know what is redox reaction. So redox reaction is where electrons are transferred from one reactant to another, where it is a combination of oxidation and reduction. Where oxidation, it is a process in which a species loses one or more electrons. So the reducing agent is an electron donor. Wherein the reduction, it is the gain of electrons or a decrease in the oxidation state of an atom by another atom or a molecule. So oxidizing agent, these are the electron acceptor. So in order for us to attain and remember the concept of redox reaction easily, we have this mnemonic in order for us to understand it better. So LIORA stands for loss of electron is oxidation, reducing agent. GIORA, gain of electron is reduction, oxidizing agent. So the steps in balancing redox reaction: first, assign the oxidation state. Second, write the half reaction. Third, balance the atoms other than oxygen and hydrogen. Fourth, balance the oxygens by adding water molecule or H2O. 5. Balance hydrogens by adding H+. 6. Balance the charges by adding electrons. 7. Make the number of electrons equal. And lastly, add the half reaction. So for the first step, we need to assign the oxidation state. So our goal is to balance this reaction. Let's talk about the fact that this is a redox reaction by assigning some oxidation state. And so we start over here with permanganate. And we know that oxygen has an oxidation state of -2. We have 4 oxygen, so -2 times 4 gives us -8. And you know that the total for the entire anion has equal to -1 as the charge for the permanganate anion. Therefore, -1 plus 8 is equal to 7, which assigns as the oxidation state of the manganese. Next one would be the vanadil ion. We know that the oxygen has an oxidation state of -2. The total for the entire ion has equal to +2 as the charge for the vanadil ion. Therefore, 2 plus 2 is equal to 4, +4, as the oxidation state for vanadium. Next one is the manganese. So, the oxidation state for manganese here is +2. And lastly, for the vanadium 4 hydroxide, we know that the hydroxide has an oxidation state of -1. So, we have 4 oxygen, -1 times 4 give us a total of -4. And we know that the total charge for the entire ion has equal to +1. Therefore, 1 plus 4 is equal to 5 as the oxidation state for vanadium. So for the step 2, we are asked to determine whether which one is oxidized and which one is reduced. So here we are going to write the half reaction. So we have vanadil ion going to vanadium 4 hydroxide. This was our oxidation. So next one would be the permanganate, which undergone reduction half reaction. So next one, step 3, we need to balance atoms other than oxygen and hydrogen. So vanadil ion going to vanadium 4 hydroxide, vanadium has a valence atom. And we had permanganate for the reduction half reaction. Manganese is also has a valence atom other than oxygen and hydrogen. So for the step 4, balance the oxygens by adding water molecule or H2O. So since I have oxygen on the right, I need to add 3 water molecules on the left. Also, for the permanganate, I have 4 oxygen, so I need to add 4 water molecules to have a balance 4 oxygen from the left to right. Step 5 would be balancing the hydrogens by adding H+. So, to balance the hydrogen on the left, I need to add 2 on the right to balance the half reaction. Next one, because I have 8 hydrogen on the right, I'll be adding 8 to the left to neutralize the reaction. Next would be step 6. I need to balance the charges by adding electrons. So here we have +2 charge on the left and +3 charge on the right. So they are not equal. We need to balance the charges by adding 1 electron on the right, and another, we have +7 charge on the left and +2 charge on the right. So they are not equal. So we will going to balance the charges by adding 5 electrons on the right. For the step 7, we need to make the number of electrons equal. So we have here 1 electron on our oxidation half reaction and 5 on the reduction part. In order to balance the number of electrons, we will multiply the oxidation half reaction to 5, making it 15 H2O plus 5 vanadil ion that yields it into 5 vanadium 4 hydroxide plus 10 hydrogen ion plus 5 electron. So next step would be addition of the half reaction. So we'll be adding the oxidation half reaction and reduction half reaction. So we need to cancel 15 water molecule for water molecule. Also the 5 electrons and the 8 hydrogen ion and the 10 hydrogen ion. That yields into um, net ionic balance equation of permanganate plus 5 vanadil ion plus 11 water molecule that yields into manganese ion plus 5 vanadium 4 hydroxide plus 2 hydrogen ion. So the reference as follows. So thank you for listening and God bless. This is Chandler M. Manlongat from CM124-1-B12. Have a good day.